So moving on to the structures and formula. What are going to be the different structures of different homologous series, and we're going to talk about them and what are their formula. Now, this is a very, very important part that you have to listen, and this forms the basis of all the other topics that we're going to study for organic chemistry. Once you're an expert in making the formulas, general formula, displayed formulas, and you have to memorize each every general formula for the homologous series, it's going to be very, very easy for you. And we're going to have some practice as well at the end of the class. Alkanes. Alkanes is the first homologous series in your syllabus. Methane, ethane, propane, butane. Now, these are the first four alkanes, meth, eth, prop, and bute. Their general formula you have to remember is CnH2n plus 1. For example, if I ask you that what's going to be the formula for a 5 carbon alkane, what you have to do is write C5 H2 times n, which would be 2 into 5, 10, plus 1, sorry, plus 2, यहाँ पे आता है. So that would give you C5H12, which would be the formula for a molecule of alkane known as pentane. So the structured formula is going to be CH4, which will tell you the number of carbon atoms and the number of hydrogen atoms. So you can see CH4, then CH3, CH3 is the structured formula for ethane. You can also write it as C2, H6, then we have C3, H7, and C4, H10 for butane. Now, these are the first four which are very commonly asked in your papers. Beyond butane are very less questions. And then we have your second homologous series, which is known as alkenes. Their general formula is very simple, CnH2n, which means the hydrogens would be the 2 times of your carbon molecules. So we have ethene, propene, and butene. Ethene would be your 2 carbon molecule. Then we have propene, the 3 carbon molecule, and then we have butene, the 4 carbon molecule. Looking at the structural formulas, C2H4, propene would be C3H6. So can you tell me the formula for butene?
C2.
No, butene.
Wait. Butene.
Yes. The general formula is CnH2n, which means that the hydrogen would be 2 times of carbon atoms. Ethene was C2H4, propene was C3H6, then butene would be
Okay, so basically 3, 4, 5, 6, 6.
C4HA. You have to remember the general formula. General formula is different for both of these. Let me show you over here as well, and you'll have an answer. If we draw a column, on one side we have alkanes, the first homologous series, and on the second side we have alkenes. The functional group is that all alkanes have single bond, and alkenes, one of those two carbon would have a double bond as well. Alkanes are also known as saturated hydrocarbons that we'll be doing in the further chapters as well. And alkenes are known as unsaturated. Got it?
Okay.
Okay. Now look at the general formula. I'll write down the general formula. The general formula for finding out the chemical formula of alkanes is CnH2n plus 2. Whereas for alkenes, the general formula CnH2n. So now what you have to do is put in the values. For example, if I ask you what would be the chemical formula of 7 carbon alkane, 7 carbon alkane. So what you're going to do is write 7 in place of n. 7,
14,
2 times n would be 14,
16,
2.
16.
So it would be 67 and 6. What about alkenes? A 7 carbon compound, C7, and what would be H?
14.
Exactly. It would be 14. That's it. Because C7H16, and for alkenes it is C7H14 because alkenes have two hydrogens lesser than alkanes than its corresponding alkanes. Why? Due to this carbon-carbon double bond. Got it?
I have a question.
Yes.
That alkenes is always with a double bond, and alkanes is with only one bond.
Mm-hmm.
Okay.
Yeah, exactly. If we draw two structures, हम यहाँ पे दो structures बना लेते हैं ना. If I draw two structures of one of them, I'll draw of butane, and the other one I'll draw of butene. Okay, can you see the screen?
Yes, I can.
Okay. So for butane, what is the chemical formula of butane? Tell me.
It's four C4
Mm-hmm. Okay.
and 10 H10.
Exactly. H10. And what about butene?
That's going to be C4H20.
Now, the double of 4. You have to multiply the carbon number by 2. 4 into 2 would be double would be hydrogen 8. Got it? Because the
Wait,
formula was CnH2n, right? And for alkanes, it was CnH2n plus 2. So if I put in the value of 4 over here, you get C4, H2 times 4, 8 plus 2, 10. That is high. You found out. Now, if we talk about butene, why would it be 20? C and C4 and H would be 2 multiplied by 4, which would be C3H8. Got it?
yes, got it.
Good. अब हम इसके disparate formula बनाएंगे. Now we're going to turn to the disparate formula. So C4H10 would be something like C, all single bonds. ठीक है? And I told you one basic rule. Carbon can only form 4 bonds, not more than that. So I'm going to start adding the hydrogens and let's see if they come out to be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So are they complete?
Right, yes, they are.
Okay. Now let's draw for butene and let's see if they're complete or not. Now butene, ene means I'm going to have one carbon double bond carbon. So now I'm going to draw it over here. First वाला ही मैं double bond कर देता हूँ. ठीक है, this is so far 1, 2, 3, 4, 5, 6. Can I add a hydrogen over here or no?
You can add on the top, but not on the bottom.
No, I can add it only on one side. You know why? Because carbon can only form maximum of 4 bonds. So if I add one hydrogen over here, I cannot make any more hydrogens on this carbon. Why? Because this carbon
Because it's 4.
first bond, second bond, third bond, and fourth bond. Same is the cases with this carbon as well. One over here and one over here. So I cannot form two more hydrogens on the upper side. Why? Because this carbon's limit has been crossed. So now if I add all the hydrogens on the side, 1, 2, 3, 4, 5, 6, 7, and 8. So this is exactly what we wrote down in the chemical formula. And these two spaces will remain empty because this carbon contains a double bond. So we cannot add another bonds over here. Got it?
Okay.
So this is the difference between alkenes and alkanes.